Welcome to the Improving Productivity with ARIS Mashzone and Adabas conference call. My name is Adrienne, and I'll be your operator for today's call. At this time, all participants are in a listen-only mode. Later, we'll conduct a question-and-answer session. Please note, this conference is being recorded. I'll turn the call now over to Jim Wilson. Jim Wilson, you may begin.
Thank you, Adrienne. Hello, everyone. My name is Jim Wilson. I'm with the Indiana Harbor Belt Railroad. I'm the Information Technology Director. I've been here for about 24 years, and please be patient. This is my first webinar that I'm presenting in. Give you a background about the IHB. The IHB is one of the largest switching railroads in the United States. What a switching railroad means is that we basically take rail cars from the big rail carriers, and we will process them and give them to a different rail carrier, or we will take rail cars from large industries, small industries, and then give them to other industries or give them to rail carriers. We've been customers of Software AG since 1984. Between the four main people that we have on staff, we have over 110 years combined Software AG product experience. So we're not really youngsters, as you can tell. We've been running Adabas Natural on the mainframe before 2009, but since 2009, we migrated the entire system to the Windows Server platform. Basically, we have 54 miles of mainline track, and basically we stretch from about O'Hare Airport in Chicago all the way down to Northwest Indiana. We have 160 industrial customers. Some of those customers you may know is U.S. Steel, U.S. Gypsum, BP Amoco, Dow Chemical, Valero, and we also interchange with all the major railroads in the Chicago area. And most of those you know would be like BNSF, CSXT, CPRS, CN, Norfolk Southern, Union Pacific. About 25% of our revenue is from switching automobile rail cars where these automobiles are assembled or manufactured. Basically, it's autos from the east that are moving to the west. And it's this 25% of the revenue that we're going to talk about during this webinar. So to give you an example, if you've ever seen these rail cars, this is the type of rail car that we're talking about. These rail cars hold, on average, 15 new vehicles per car. And you can see, here's the end of the car to here. Each one of these cars averages about 90 to 92 feet long, and the average train is 7,000 feet long. So these are very long trains. This is a picture of our Gibson auto yard. We switch 600 to 700 auto rail cars every day in this yard. Now the problem is that our rail car volume has increased 22% over the last 10 years, where the size of the yard, we really have not been able to expand very much. So that yard that you're looking at processes approximately 216,000 rail cars a year, which equates to about 3.2 million new vehicles annually. Now the IHB is a very small company, and you can imagine the other parties that are involved between all the auto manufacturers, how big they are, and then take all the big Class 1 rail carriers like the BNSF, the Norfolk Southern, the CSXT, how big they are, and you can imagine how much pull we have in trying to control this process. However, we are a very vital part of this process of switching these rail cars from the east to the west. So here is our opportunity. The Gibson Auto Yard is the only operation of its kind in North America. And the reason why is because to minimize damage to the automobiles inside those cars, you basically, when you are switching those rail cars, you have to shove them to rest to minimize the damage. I believe the impact is supposed to be less than 4 miles an hour or less than 3 miles an hour. So you can't do a normal operation, a normal rail operation for switching these cars. So this rail yard that you saw has been the premier site since 1992 for switching the rail cars. And so now the traffic volumes have increased so much that the yard becomes too full, and we are being accused of taking too much time to switch these cars. So we get a lot of pressure from the bigger railroads and from the auto manufacturers. So trying to work towards a solution, in July of 2012, we set up a process improvement team to figure out how we could reduce the yard dwell. And basically what yard dwell is calculated by from the time one of those rail cars arrives at the yard until the time that that car leaves that yard, that is dwell. And if that dwell is too high, then we have problems. The team was set up from people from our transportation department and our information technology. So basically we've been using several KPIs over the last 20 years to monitor this traffic. And what this team was going to have to do was come up with some new KPIs, really look into the process more in depth to determine how are we going to be able to improve switching in the yard, improve the performance with the current operating plan. So based on the information we started capturing in November of 2012, by July of 2013, this year, our transportation folks came up with a new operating plan to help improve the operations. So the KPIs that we use is the previous day yard dwell. How long did the cars previous day, how long were they in the yard? The daily workload of pin pulls, and a pin pull means that if you go back to that rail car, every time a car is switched, you have to pull the pin between two rail cars and put those rail cars in different tracks. So that is our workload activity. The previous day's rail switching activity, so how many rail cars did we switch and how many pin pulls did it take to switch them? The number of cars reswitched, which means we don't want to handle a car more than once. When we receive a car, we want to handle it one time and then put it into an outbound train and get that train out of town. We don't want to put it into track 1 and then later on in the day have to put it in track 5 and then have it go out to its outbound train. We also keep track of the arrival to switch average hours. So when a train arrives, what time, how long did it take before that train arrived before we first switched that train? And then we also keep track of the oldest train that needs to be switched. We receive anywhere from 9 to 11 trains a day, and we make up 9 to 11 trains a day on the outbound side. And we also kept track of the number of cars that are over 36 hours old. For the year 2012, our target was between 27 and 30 hours that we wanted to keep cars in the yard. We wanted it to be less than 30 hours. So obviously, if cars were over 36 hours old, we needed to figure out why was that and what could we do to get these cars out of town. So we had a lot of data that we really needed to look at that we really weren't looking at before. So once we started capturing data, we needed to be able to present the data as easily as possible for our managers to view, to be able to make decisions. So we had a choice. So we're going to do this through spreadsheets, which takes a lot of time, download data, compile it into graphs, distribute them to people. I mean, that's one way we do a lot of our reports are done that way. Well, I knew that this had to be more of a real-time review process. So could we do it through natural? We could, but could we do it through .NET applications? And our last choice was ARIS and Mashzone. So we did a few tests with ARIS and Mashzone, compiling some data to see if our managers liked it. And Software AG came in 2009 or 2010 and did a proof of concept for us. And this is where I really would like to thank Silvio, Mark Brokoff, and Paul Braden from Software AG. They came in, spent a week with us, showed us a lot of different things with Mashzone, business process management, and that's where I was really sold on the ARIS Mashzone. So we purchased it soon after that and started using it for minor applications. So why did we go with ARIS Mashzone? It was easy to use. I like the flexible charting tools. I like the variety of interfaces that Mashzone could use spreadsheets, hooks into SQL, CSV files we can send into the system. In the future, we plan on going directly from natural and database directly into SQL so that we can get more information into Mashzone quicker. And Mashzone fit nicely into our IT department. We have a very limited budget. On railroads, most of your capital goes to taking care of the rail, the yards, and bridges, things like that. So IT doesn't really get a lot of money to be able to spend on fancier IT software. So this is where I'm going to jump over into our ARIS Mashzone and show you a little bit of how we use that. So I'm right into the Mashzone, and what we're looking at here is this is September 2013 data, and the nice thing, this is one of our main Mashzone applications that we use. And this one's nice because it has 6 different KPIs all together on here for us that we want to track. The top one you'll see is that yard dwell that we talked about. And since July 2013, since we've changed our transportation process, you can see that we lowered our target to 27, and you can see most of the time that we are below that. So this whole project that we went through to trying to get efficiency in that rail yard has been a major success for us. Second one we see down here is the inbound auto cars and pin pulls. How many cars were we receiving a day? And the number of pin pulls, how much work do we have to do to switch those cars? One thing that's really interesting, and this is what we saw back in November, was that very inconsistent on how the rail cars are coming to us. And we have no control over the number of trains that will arrive, how many cars are going to be on those trains. That is really driven by the Class 1 rail carriers and the auto manufacturing and assembly plants. So it's very difficult to plan your operation when the inbound cars fluctuate so much. Sorry about that. We have hearing testing going on outside out there, and somebody was backing up their truck. Here's the arrival switch that we talked about. We set an operating plan that we want to be able to switch a train. When a train arrives, we want to be able to switch that train within 18 hours of that train arriving. In last month, you can see that we're always under that 18 hours. I'll go back and show you later how that wasn't the case 9-10 months ago. But it's very interesting, and you can see, comparing these two graphs together, that with the fluctuation in traffic, how our arrival to switch fluctuates. As we get more cars, you can see that it takes us a little longer to process. And here's the number of cars that we actually switched. So this was how much work we actually did in the yard and how much work it took to process those cars. So our transportation folks really liked having all this data compiled on one application that we could print out for them once a week. They could review and help them see what's going on. And then remember, we also talked about the number of cars that we handled twice. This was our target, that because our yard was so small, we knew that we were going to have to handle a certain percentage of cars twice, but we wanted to keep that under 25%. And you can see that we've been doing that also in the last month. Now here's what I like about Mashzone, is I can go up here now and I can say, well, let's go back to, I can look at February 1st all the way to current, and very quickly it assembles all that data for us, and we can see when we were having trouble earlier in the year, and you can see when we changed our operating plan and the effect. And we didn't lose any traffic during this time frame. We are actually handling the exact same amount of cars, if not 1 or 2% more than what we were handling back here. And same thing for our arrival to switch. You can see that we were almost consistently over that 18 hours on the arrival to switch. And same thing with our reswitch ratio. So Mashzone really helps us focus on our productivity. And I really like the flexibility where now I can just say, if I just wanted to look at February 2013, Mashzone will come back and we can just look at the February data if I want, and very quickly our managers can adjust and look at different time frames they want to look at. So we built different tabs for different scenarios we want to look at so that our managers, some of the managers only want to look at a couple of the different KPIs. So one of them really only wants to look at dwell. So now he has the ability to compare dwell from 2 different months or whatever time frames he really wants to. So this is comparing February of 2013 to September of 2013. And they can look at our targets and how well our guys are performing. And we actually used these types of reports when our people went to gave a presentation to the auto manufacturers and to the Class 1 carriers. We actually use screenshots right from our Mashzone to build into presentations so that we can inform the manufacturers and the Class 1 railroads how complicated this switching is. They think it's just as simple as you're just switching rail cars just as everyone else switches rail cars. And that's where we had to show them that we really didn't. There was a lot more to it, and that the data was so different. So it really helped us out, and they've really bought into the process that they were able to help us work towards a solution of being able to switch cars quicker. So here's our arrival to switch. This to me was one of the key leading indicators, because if as our arrival to switch started to increase, we knew that we were going to start getting in trouble with dwell. And this usually started to increase before we had trouble with dwell. So this really helped us be a little bit more proactive as much as we could by having this information. And then having our reswitch side by side also. And we can look at different time frames, which is nice. So let's say I wanted to look at June. And I could look at June compared to September if I wanted to very quickly. So one of the other things that we used this for, which was really interesting, we started out with these KPIs, these types of applications. And then we, let's see, do I have to go to home to get to the other? A lot of railroads and a lot of different companies will try to use what they'll refer to as like simulators or a playback recording of activity in their rail yards. So what we did here is we were able to use Mashzone, and we were able to take the rail yard that we have, and we took all the tracks for the rail yard, and that's what the blue means. This is the capacity of that track. So this is GR00. It has the capacity to hold 77 rail cars. Then side by side, what we did was we put how many cars at this snapshot of time. So at 9 minutes after midnight on April 13th, there were 67 cars on that track. So we were able to get an idea of where were some of our bottlenecks. And what we did was we took a snapshot every 30 minutes, and then we loaded this data into Mashzone. And let me see if April 13th is a good day. Hopefully it is. And so we were able to, every 30 minutes, we take this snapshot, and we can see how the yard changed with trains that came in and trains that we departed. Trains that we would arrive trains on these tracks over here and arrive trains on tracks over here to the right, and most of the switching activity would be done on the middle tracks inside here. So we can see through the course of the day how the rail cars were switched, either coming in or departing. And a lot of products like this that people would want to sell you for rail yard operations, they'll cost $300,000–400,000. Well, Mashzone didn't cost us anywhere near that, and it was very nice, very handy that we were able to have Mashzone take care of that for us. And we just had to send the data, set up the Mash application, and it was very insightful for our manager. And for our transportation manager, what it helps him do is if he goes on vacation for a week, he can come back and we can load the activity while he was gone, and he can actually check to see how well were his yard supervisors, how well were his yard masters performing their duties as far as switching activity in the yard. So this is very, very handy as far as I'm concerned. So in the future, we really believe that we're going to be able to use ARIS Mashzone for almost any area on our railroad that we want. It's just a matter of gathering data, looking at our different KPIs, and setting them up in the MASH apps. So we have another major rail yard is our Blue Island yard, where we do receive a lot of trains also. I think we receive 12 to 13 trains a day there, and we depart probably 12 to 13 trains a day also out of there. When that yard gets in trouble, or we want to start fine-tuning productivity in that yard, we will start using the MASH apps for that. For crew productivity, we can use this for revenue analysis, accounts receivable, for many business processes. We believe that we're going to be able to use the MASH apps for. So that's all I have. If there are any questions, operator, you can open up the forum for questions, please.
Thank you. We'll now begin the question-and-answer session. If you have a question, please press star, then 1 on your touch-tone phone. If you wish to remove from the queue, please press the pound sign or the hash key. There'll be a delay before the first question is announced. If you're using speakerphone, you may need to pick up the handset first before pressing the numbers. Once again, if you have a question, please press star, then 1 on your touch-tone phone. And we have Craig Swarney online with a question. Please go ahead.
Are the inputs for the graph straight data, or is it actually real-time code that's deriving the answer?
Currently what we're doing is we run some batch jobs at between 5 and 6 o'clock in the morning. And right now what we're doing is we output them to CSV files. Some of the data we actually have operators manually input into. So right now we have a hybrid of the two. In the future, what I'm hoping to do is go directly from natural to SQL so that I'll be able to try to populate it as close to real time for certain applications.
Okay, but it's always, the product itself is always just reading the data. It's not calling any code.
I don't know that the product can call code. We don't have it set up that way. So what we're going to do is just feed directly into SQL, and then as you call up an application, you just hit refresh and it'll bring the data back. Does that answer your question?
Yes, thank you.
Okay.
And once again, if you have a question, please press star, then 1 on your touch-tone phone. And we have no further questions at this time.
Okay, thank you. That concludes the call for today.
Thank you.
Thank you, ladies and gentlemen. This concludes today's conference. Thank you for participating, and you may now disconnect. Speakers, please stand by for your post-conference.